So for our lesson today, I got a couple of things here, just a bit of housekeeping I want you to have a look at. There's a link that I put here, which is for student, what do you call them? I guess they're like tutors, peer tutors. There is a timetable if you follow that link. If you feel that you could be helped by a student tutor, you can contact the people that are on that list. They have contact details. They also have a walk-in facility that is in upstairs in room 229. And so you can go walk in there and, well, let me just open it to show you. You can see there the times that are available. They're not available all the time. These names are names of students, but they're students who are very confident in their IT and certainly would be able to help you with your IT studies. So you can contact them. I think you can walk in at these times and have a meeting with one of these students, and they're not going to, if you look at this, it says they're not going to do your assignments for you. But if you're having trouble with any of the understanding, they can help you with that. All right. So that may be of use to you. I was asked to share that with you, and I'm very happy to share that with you. Hopefully that will be of use to you. You can just follow that link and get some more information on that as you need it. Another thing that I've got here for you is there's a little video that I'm not going to go through during class because you can look at that anytime you like. It's there. And I didn't make this video. You'll see that it's done from some people in Silicon Valley. I chose this one because it's only a 4-minute video. But this 4-minute video, as it says, is about Boolean logic. It really just covers the concept of not, which we refer to in our lecture today as negation. Not negation, so making something the opposite of what it would be without the not. So it has a bit of an explanation on how that works with Boolean logic, but also the conjunction and the disjunction or. So and or, how do they work when we're putting two conditions together? This lecture, if you look at it, you'll see he's using symbols that I'm not using in the lecture. He also makes some tables. And so I'm recommending it to you because actually in the textbook, if you want to call it a textbook, the reference book, which is recommended for this course, they do the same. But I noticed that they don't come up in the lecture. But so I don't believe that this will be on the exam, but it might be. I don't know. Anything out of the lecture, out of the textbook could be, I suppose. No, I don't think so. But I think it's a good backup. And as I said, I'm not asking you to watch a 40-minute video. It's a 4-minute video. So have a look at that sometime, and maybe that'll be of help for you. So today's lecture is on this, which is about selection, and selection being in a algorithm or a computer program. We're talking about selection. We also use the term branching, meaning that we can take a computer program and make it branch to different points, or we have different paths that we can make. That's the idea of a branch, isn't it? You know, from the main tree, we have something splitting off. So think of something splitting off and branching to a different direction. We're allowed to do with a thing called selection. So when we think about selection, you should think about in a computer program or in an algorithm, we would use words like if, then, else, for example, or just if, then. That would be how we would implement some kind of a selection. If this is true, then we're going to do that. Or we do something else. That's one way of doing it. We also talk about branching with a loop. We can loop through, which sometimes we use statements like, while this is true, do this, while true, do this. And so, yeah, the image that is on our first slide there represents that. I think we've got two different paths that we can take. We can go that way or we can go that way. If this condition is this true, we go that way. Otherwise, we might go the other way. And I guess the image at the bottom represents the fact that you could have many different paths that you could take, yes. And each of those might have an if condition at the point where it branches out. But I hope that those images give you the idea of branching. So why do we need to have branching? Do you remember from the first couple of lectures, we talked about the CPU cycle, fetch, decode, and execute. Remember that? So the idea being that we fetch one line of code or one instruction, because a line of code is going to be like an instruction. Then we decode it, then we execute it, then we fetch the next line of code, and okay, etc. So you can have many, many lines of code in the computer memory at a time. And what we're able to do with our computer programs is we're able to actually change the order in which we process some of those things by going to a different place. Now, in the first computer programs that were written in the machine language, which is our second generation languages, there would be a thing which would just be a go-to, right? Go to another line, you know, go to another line. Instead of going to the next line, go to a previous line or jump to a different place. Now we have, if some condition is true, we're going to perform some statement, and we might not perform that statement if that condition wasn't true. So when it talks about the default behavior, that means what we would do if we didn't have the condition. If there was no condition there, we would just go one line to the next line. But because we have a if structure, control structure, we can control where we'll go in the program. So we can choose where we're going to go. Now, a loop is mentioned here because a loop is kind of a special kind of branching. What we do with a loop is we go back to a previous line in the code. And so that means that we're going to repeat a bunch of code over and over again until a particular condition changes. And so we usually use like a while statement for something like that, or a for statement. Don't need to learn about for statements in this course, but you will later, I suppose. So a condition will be set, and we'll use something like, if this condition is true, then we're going to go this way. Or as I said, we could have a condition with a while statement. While this condition is true, we're going to keep going in this loop. And when that condition becomes not true, then we exit from the loop. That's the two different ways. So we have this gentleman here. His name was Boole, or his surname was Boole. And so his name became used for a type of, we call it algebra. So he was a mathematician. And so you'd recognize algebra as being part of mathematics. And so he developed, or he described, I don't know if you'd say developed, because I think sort of from a point of view of Aristotle, Plato, they did use logic, which is very similar to Boolean logic. So I'm not going to say that he sort of invented all of this, but he described it in a way that we can use it in our computing quite well in the 19th century. So in the 1800s. And so we have this thing that's called Boolean logic. So we have this thing called Boolean statements. Now, the idea of Boolean is that something can be either true or false. And true and false are mutually exclusive. If you're true, you're not false. If you're false, you're not true. So you could say the definition of false is to be not true. And you could say the definition of true is to be not false. And so we can use not in that way to change things as well. So maybe we'll see that as well. Let's have a look at this. Examples of some Boolean statements. These are Boolean statements because they can be either true or false. John is hungry. John's hungry. That's a statement which is either true or false, depending on what time of day it is, right? You know, if he hasn't eaten since yesterday, that's probably true. If he just got up from the table, might be false. But it will be either true or false. It won't be both. Right? If he's hungry, then it's not false. All right. If it's true that he's hungry. Toronto is the capital of Canada. That's a Boolean statement, but it's actually a false statement. I mean, there's no condition under which Toronto is the capital of Canada. The capital of Canada is Ottawa. So that's not true. However, I don't know, if you went back in history long enough, Toronto may have been the capital of Canada, but in those days, I think it was called Yorktown. It wasn't actually called Toronto in the very, and when it was a capital, then Canada wasn't a country. It was a colony of England. Anyways. Oh, and yeah, if you went back far enough, then it was French. So anyways, in no case was there Toronto a capital of Canada. That never happened. Age is bigger than 18. That could be a person, right? So you have two different people. This one, their age is bigger than 18. That's either true or false. And another one may be there. So that might be true. And another one who's a child, that might be false. Name has less than 2 characters. I don't know what they mean by that. Do they mean the word name or they mean somebody's name? I don't think that you could have a name with less than 2 characters because it would be a single character, right? So maybe that would be a false statement. Now, those statements there are all Boolean, meaning that they can either be true or false, but they can't be both, or they can't be something else. And we got some others that are not Boolean. How old are you? This is a question. How old are you? Is that Boolean? It's not true or false. It's, I guess they could ask, it's just not. If you wanted to make it something that was true or false, you could say, are you old? And then it would be subjective as to what is old, I suppose. Add 2 and 3 together and you get 5, right? Is that Boolean? No. If we said 2 plus 3 equals 5, then that could be Boolean because it's true, right? But, just saying add 2 and 3, that's not Boolean. All right. So what do we do with a decision in programming? As it says, we check to see if the condition in the decision is true. If it's true, then a certain bit of code is performed. If it's false, then that bit of code is not performed. It's kind of as simple as that. And here's an example. Perhaps you had a purchase that you wanted to make, and the store was offering a 10% discount, but only if the purchase amount rose to the level of 1,000 reals. So in other words, if you had a purchase amount of 900 reals, you wouldn't get a discount. But if you had a purchase amount of 1,050 reals, you get a discount of 10% on the 1,050 reals. And so you could maybe do something like this. I hope you recognize this as being a flow chart. And some of the flow chart is put into place already. We see we've got our start and our end, and we've got a bunch of inputs and outputs. So we've got an input here, which is what is the purchase amount? And we're required to pay the purchase amount. And then we're going to have a thank you statement. Now, somewhere here in the middle, we're going to take care of that condition. Is the amount raises to the level of 1,000 reals? Because if it does, we get to have a discount. So in here, we would represent that with what? What kind of symbol is going to represent, a condition? We've seen this symbol before. It would be a diamond, right? A diamond. Yeah, a diamond. That's right. So notice the word that we're using here, if, and we'd see that in our computer programming language as well. If condition true, then we do something. So if the purchase amount is over 1,000, then we get 10,000 discount. So there's our diamond. Now our diamond's been squished a bit, so it'll fit into this page. But I hope you can still see that it's a diamond, right? We've got flow control coming into the diamond, and then the diamond has in it a condition. And if the condition is true, then we follow the yes arrow. And if it's false, we follow the no arrow. We don't follow both the yes and the no arrow, right? We follow one or the other. And so if the amount was 900, then we would have to go the no. And what that would mean is we would miss out on this process. But if the amount was bigger than 1,000, then we would go the yes, and that means we would perform this process. So the difference between the yes and the no is this process here, right? If this condition is true, then we do this. Otherwise, We just keep going. Now notice that this thing here, you're required to pay the amount. That's always going to happen. Why is it always going to happen? Because if it is true that the amount is over 1,000, we're going to do this process, but we're still going to do this. This process is always going to happen, but this process will only happen if this is true. So that's the difference here. This process would be the process which is inside an if statement where you have a then. If this condition is true, then do this. If it's not true, what do? We go to the next line of code. But when we're finished doing this, we go to the next line of code. So both of them will end up going on that next line of code at some point. That's an if statement. Now you can have, notice that was an if statement, but it didn't have an else. It was just an if statement. If this is true, do that. When we're finished, we go to the next line of code. There's another more, well, I don't want to say it's more anything, right? There's another type of if statement, which is going to have a, if this is true, do that, else do something else. In which case we've got we've got a thing where we've got two possibilities. We're going to do one of them, but depending on what is true or not. We're going to use this term consequence. Consequence is going to relate to those processes which we perform depending on whether the condition is true or false. Now, in the previous example, we talk about skipping. When the condition was false, we skipped over the condition, the consequence. That was, we didn't calculate the discount if the amount of the purchase was less than 1,000. But if the amount of the purchase was 1,000 or more, we did calculate the discount. So let's look at another one where we can see maybe this if then else idea. A waiter asks a customer their age. If they're above 18, it gives them a menu. The waiter takes the order. Well, this one doesn't have this is actually, we'll get to the other one in a minute. This is actually the same structure as we just looked at. I hope you can see that. So what's going to happen here is they're going to take the order, doesn't matter which. If the person's over 18, they get a menu and then they take the order. If the person is not over 18, they take the order, but without a menu. So we got to fix that, I guess. So in every case, we always take the order, but if they're over 18, we show them a menu. Now, what if, this is where we're getting into the if then else idea. What if we change the process a little bit so that we give a special menu for children and we get a special menu for another menu for everybody else. So if the person is not more than 12, we give them a kids menu. And if the person is more than 12, we show them a normal menu. So here we have two mutually exclusive things, right? You're going to get one menu, but it depends on your age. If you're more than 12, you get the normal menu. If you're less than 12, you get the kids menu, but you don't get both. The way this would be represented in a Python program would be if age bigger than 12, show menu. Else, and this is where we get the else because we got two different possibilities, right? Else, show the kids menu. Then afterwards, we go on with the rest of the program. So this is an if then else. I hope you can see that that's different than the one that was just an if then. If then, we only had one thing and we skip it if it's not true. If then else, we have two choices and the else is the second choice. The else is what we do if it's false. So that's a cooler one, I think. Is it boring? Or you're just tired? So when we've got two possible choices, we're going to do an else. One of the two has to happen. That was very different than the first example that we had. In this case, one of the two has to happen. We have to do the kids menu or we do the normal menu. Yeah. All right. So here's another one. Now this one is now getting into more complicated. Now in the first slide that we had in today's lecture, there was an image with lots of arrows going off in different directions. So you can imagine we could have lots of different decisions breaking out of the from whatever's happening in the previous decision. So here we've got a situation where there's some kind of I don't know, some kind of ageist sort of thing going on here, right? Extreme rides, if you're not, you have to be between the age of 16 and 55 to ride this extreme ride. So so the first thing is going to find out, are they more than 16? If they're not more than 16, that means they're less than 16 or else equal to 16. They don't get to go on the ride. If they are over 16, doesn't mean they get to go on the ride. Now we got to check, are they over 55? Because if they are, they're not going on the ride. If they're less than 55 and they're bigger than so if they're going on the ride, that's because they're bigger than 16 and less than 55. That's how we got here, right? Bigger than 16, but less than 55, get to go on the ride. If you're less than 16 or you're more than 65, you're not going on the ride.
The input, the word thank you, is necessary? Do we have to put it?
Well, in this program we do. That would be a business rule, right? So basically, I guess the people at this park said that we want to thank all our guests. So, you know, when you write a computer program, you'll come up with some business rules before you write the program. You know, maybe you don't want to thank them, you know. But I guess in this case they do. So that's what's called nested selection. Another example of nested selection would be what happens when we do grades. So we could have something like this. If the mark is, well, let's do smaller, right? Is less than 60, then we would say grade equals F. Else. So what the else is going to be is if this is not true. If this is not true, that means the grade is 60 or more. If the grade is 60 or more, else if the grade or the mark is less than 75, then grade equals C, I guess. I'm not sure, but I think so. Else. So now we got a situation where if the person's grade was somewhere between 60 and 75, they get a C, right? Now, if the grade is not less than 75, then we're going to do another test. If the grade is less than 90, then grade, so you have to mark. It's less than 90, then grade is equal to B. Else, if none of those things are true, so the grade's not less than 60, it's not less than 75, it's not less than 90, then it must be 90 or more. So the grade, you don't have to have another, is equal to an A. So we could have something like that. Now, how would that be represented? We would say here, get mark. That would be an input. And then mark is, what's that, less than 60? So that's going to be thing like that. So if the mark's less than 60, then if that's true, or you could say yes, then we could just say that we could even output it. That's F, right? And then we can have that go to the end. But if that's false, let's go down this way. Then we're going to do another thing here, which is the mark is less than 75. And if that's true, then because the mark was not less than 60, but the mark is less than 25, we're going to have this is going to be our C. And our output will be our C. And if it's false, then we're going to go to it. Oh, well, I'm kind of wrong. Let me just do it here. If it's false, then we're going to do another one, right? Mark is less than 90. And if that's true, we're going to have our mark being a B. And if that's false, then we're going to test to see if the mark is, oh, if it's false, then our grade is going to be an A. And then all of these will join up with the end. So we got lots of different ways of getting to the end, but you see the nested ifs, right? Now to get to this A, what we had to have was the grade had to not be less than 60. It had to not be less than 75. It had to not be less than 90. If all of those things were true, then we get to have an A. Does that make sense? All right. So let's look at logical operators. Logical operators are used to join two conditions together. There's two ways that we can join them. We can join them with an and, which is called a conjunction, or we can join them with an or, which is called a disjunction. Now, put simply, and by the way, if you want to get a good review of what I'm going to talk to you about in the next couple of minutes, look at that 4-minute video that I put there, right? He discusses this pretty well, I think, and he uses nice little tables and symbols to explain it in a way that might be useful to you later if you really want to sort of get into this, right? But the idea is if you have an and, you got two conditions. If we say, if condition 1 and condition 2 are true, that statement there, which has two conditions in it, is only true if both things are true. If one thing is not true, then the whole thing is not true. Does that make sense? They both must be true. Must both be true for it to be true. That's what we call a conjunction. And I hope that's explained well enough here for you. Condition 1 and condition true, because it's got an and, only true if both of them are true. If either one of them is not true, then the thing that's got the and in it together is not true. Or is the opposite way around. It's the opposite. It's the logical opposite of an and. And so when we say, if condition 1 or condition true are true, that whole statement will be true if either of them are true. So condition 1 can be true and the whole thing's true. And condition 2 could be false, but the whole thing's true just because condition 1's true. On the other hand, condition 1 could be false, but condition 2 is true. And then the whole thing is true because of the or. So the or is logically the opposite. And so that, I hope, is explained here okay for you. Condition 1 or condition 2 are true. That means it doesn't matter which one of those is true. They could both be true, or as long as one of them is true, the or will be satisfied, and that will be treated as true. So the falsity of an and condition, a conjunction statement, if the opposite of an and is an or. Okay, so maybe that's the easiest way for you to remember. I don't know, but if we say that if condition 1 and condition 2 are true, if we then said, if not condition 1 and condition 2 are true, the opposite, because notting makes it the opposite. That's negation. So putting a not in front of it makes it the opposite. Well, what that would mean is that we would say, well, if either of those or is false, then it's going to be. On the other hand, the opposite of an or is going to be an and, right? The opposite of an or is going to be an and. So maybe it's best to look at it with an example. Your car is clean and new. It's a conjunction because we've got two conditions. The conditions are clean and well, yes, and new. So the only way that this statement is true is if both your car is both clean and it's new. So in other words, if your car is dirty and old, then this is not true. If your car is new, well, that's not true yet. If your car is new but dirty, it's still not true. If your car is clean and old, it's still not true. So car is clean and old, then it's false. Car is dirty but new, then it's false. Car is old and dirty, then it's false. The only way it can be true is if both of those things are true. And now the negation means if we said a not in front of it. If we said, not your car is clean and new, well, that would mean that your car is either dirty or it's old. So that's what we mean there. And we do that in computing. We actually do that. We take a statement, we put it in brackets, and we just say not. So not your car is clean and new means your car is dirty or it's old, because that's what not of an and means. The not of an and is an or, right? Okay, now we're starting with an or. Your car is clean or new. So this can be true if any of these things are true. If the car is clean but it's old, that's okay, still true, right? Because of the or. If the car is dirty but it's new, that's okay, because one of those things is true. If it's clean and it's new, both those things, well, it's okay too, because the or is much more inclusive, right? Any one of these things could be true. If the car is clean and the car is new, that satisfies the or, because as long as one of those things is true, then it's true. If it's clean and it's old, it's still true. If it's dirty and it's new, it's still true. But on the other hand, if it's dirty and it's old, then this is no longer true. Now, if we put a not in front of this, not your car is clean or new, that would have to mean that your car must be, I'm going to use an and. If we put a not here, it would be your car is dirty and old, right? Running out of time. We got 10 minutes. Sorry, your car, if we negate it, then we're going to have to say your car is dirty and it's old. Okay, so negate the following. You guys help me. The car is beautiful. You negate it by putting a not in front of it. Not the car is beautiful would mean your car is not beautiful, or the car is ugly, or whatever. Car is not beautiful. Not next weekend I will go to the beach or the desert. So if I'm going to not something that's a disjunction that's got an or in it, notting an or gives an and, right? So that would be next weekend I will not go to the beach and I will not go to the desert. So when we knotted an or, we got an and, right? So again, not this one. Not I like burgers and pizzas.
I don't like burgers.
I don't like burgers or pizzas. Fire fine. Not this course is interesting but difficult.
It's not.
This course is not interesting. Now the but, I'm sorry, the English there would have been, you could replace the but with an and. You could have said this course is interesting and it's difficult. So if you knotted that, you would say this course is not interesting, or this course is not difficult, right? It's not interesting or difficult, right? He is between, okay, we got an and there. He is between 18 and 35. So to say not he is between 18 and 35 would be, could be he's younger than 18, or very good. So you saw there was an and. When we knotted it, we got an or. Very good. So we'd say he's younger than 18 or he's older than 35. Very good. I got an A in the midterm, or I dropped. Because it was an or, when we knotted it, we got an and. I did not get an A, and I dropped the course. The Fahrenheit thing. So we did a Fahrenheit thing before, and we get some temperature things, but this one here, I don't know. I don't want to do the whole calculation thing again. Let's just look at the temperature. If you have a temperature of 0 degrees Celsius, anything less than 0 degrees Celsius, that's going to be freezing. You could output that, right? If that was false, it's not less than 0 degrees, then we could do a test to see if the temperature was bigger than 100. And if it's bigger than 100 degrees Celsius, then we could have an output of boiling. And if that's not true, then it's just, I don't know. And so, I mean, I just tried to simplify that. Don't worry about the calculation, but we get something like that. We got our temp in Celsius coming in as an input. We actually got that from our Fahrenheit calculation. But when we got our temperature in Celsius, If the temperature is less than 0, we're going to say it's freezing. If it's more than 0, we're going to say it's boiling. We actually have a nested if, right? We have a nested if because we say, all right, well, if it's less than 0, we're kind of finished, right? It's freezing. But if it's not less than 0, well, we have to check to see if there's this other condition, which is true, you know, is it bigger than 100? Because if it is, then we got to say that it's boiling. So let's do it with these temperatures here, 20 degrees Fahrenheit. The calculation is you take the temperature, you subtract 32 from it, that'll give a temperature of -12, then you multiply that by 5/9. 5/9 of -12 is approximately 7 degrees, but it's -7 degrees. 20 degrees would be freezing, right? Because it's less than 0. Does that make sense? I would take this -7 degrees, put it into here, and I'd say that it's freezing. I don't know why we use this American stuff. I mean, I don't know if you guys are ever going to go to America. Nobody else uses Fahrenheit. 120, even Canadian stuff uses Fahrenheit. 120 degrees Fahrenheit. That's a really, really hot day. You know, it happens like once a year in Qatar. And so you can do the calculation on that. You know, subtract 32 from it. You're going to get 88. I multiply that by 5/9. That's going to be 440 divided by 9. It's going to be 50 degrees approximately. That's a hot day. So 50 degrees, it's not going to be less than 0. And it's not going to be over 400. So we're just not going to say anything about it. It's just a hot day. It's not boiling and it's not freezing. 300 degrees Fahrenheit, on the other hand, you run that one through there. Take away 32 from that, you get 268, multiply by 5/9. And I think it comes out to about 150 degrees. That's not less than 0, but it is more than 100, so it's going to be boiling. 300 degrees Fahrenheit is too hot for people. That's sort of 300 degrees Fahrenheit you do in your oven. All right, so Halas and Zain. Any questions? I'm going to stop sharing. Kind of ran out. Hey, Joshua, who else we got there? I got like 5. I hope you guys, you know, you're supposed to come to class. So I got like 5 people there. So I'm hoping you guys will give me a little excuse. Anyways, cheers. That's the end of that.